Hello everyone. This is a brief video on describing what we're going to be doing this week in experiment number 4. So basically, our ultimate task is going to be building the circuit that you see on the screen, which contains one voltage source and 6 resistors. And our task is basically going to be to first simulate this circuit and determine the node voltages. So the voltages at the nodes that appear in the circuit, just like last week. But this week we're going to be building the circuit. We're going to physically build the circuit. So the next thing we're going to do is to construct the circuit. And to construct the circuit, you need these 6 resistors. You're going to get these 6 resistors from the bins, the resistor bins in front of the class, near the board, near the whiteboard. And then when you pick up these resistors, of course, they're practical resistors, so they're not going to be exactly the values that we show here. So the first thing you'll do is you'll actually go measure what those actual values are. And there is a way to do that by using the multimeter, which is a component, which is an instrument that's on every bench. You can also do it by using the common multimeter, ohmmeter, that's by the bins. But I think it would be more practical if you measure these 6 resistors in your laboratory. But again, the basic thing is we're going to simulate the circuit and get the node voltages just like last week. Then we're going to build a circuit and measure those voltages in the practical sense. And we're going to compare to see how close we get. How close are our hand calculations to the practical values. Now, before I describe how we're going to go this, I should tell you that when you pick up resistors, when you pick resistors in the lab, there's going to be a little bin, a little box that contains all the resistors, and each drawer contains multiple resistors. So make sure you pick the right resistor from there. Also, when you pick up the resistors, you'll see that there's some color codes on them. So you can find the resistor color codes anywhere pretty much. You can, if you search for resistor color code, you'll have hundreds or thousands of descriptions of what this is. So let me just show you one of those codes or descriptions. So basically, if you look at the resistor, it has this cylindrical shape, as you see, and it's got 2 leads. Okay, these are the metal points or metal wire-looking things that stick out of the sides. But when you look at the resistor, you'll see at least 4 colors. And some resistors have more than 4 colors that describe what the actual resistor value is and what the tolerance in the resistor is. So typically, when you look at the resistor, one of the sides will contain the primary colors. And the primary colors are written here. It's the black, brown, red, orange, yellow, green, blue, violet, gray, white. So these represents digits from 0 to 9 as shown. So when you read and by the way, there's another, the 4th band. These are the first 3 bands. The fourth band is usually typically, in our case, either gold or silver. I doubt we'll have red or brown, but it'll be typically gold or silver. So you start from a side that has the color that's not basically gold or silver, because you might have this upside down. So the question might be, which side do I read this from? With some experience, you can get a hang of this. But basically, these 3 colors tell you basically either the digits in terms of the value of the resistor or the multiplier. So, for example, if you see something like 1, 1, 1, or brown, 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 it means 11 times 10 to the 1. So basically, this 3rd band is what's called a multiplier. So it's the power that goes on a base 10. So if you see, for example, 3rd band being orange, that means multiply by 10 to the 3, or 1K or 1000. If you see 2, that's 10 to the 2 or 100. If you see green, it's 10 to the 5 or 100,000. So that's how the color code kind of works. So if you see, for example, orange, 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 it means 33 times 10 to the 3 ohms, or 33,000 ohms, or 33 kilo ohms, right? That's what it means. So like the example that's shown here, it says 1K, 1 kilo ohm, or 1,000 ohm, and that's because you're seeing red, black, and yellow, right? So if that's the example, well, that's not the example over there, but it's the example that's down here, sorry. So red, black, yellow is, you have a 2, a 0, and this is 4, right? Yellow is 4, so 20 times 10 to the 4, which means 20 times 10 to the 200 times 10 to the 3, or 200 kilo ohms, right? That's the value. The fourth band you'll see is that's the tolerance. So that's the tolerance. So what you're seeing there is the amount of variation you will see in the resistor. So if the resistors, for example, that's shown here is 1K, right? 1 kilo ohm. So what you're seeing there is you're seeing the first color is a brown, then the next color is a black, so you're seeing brown, black, so that's 10, right? And then red is 2, so it's 10 times 10 to the 2, or 10 times 100, or 1,000. That's why it says 1 kilo ohm, or 1,000 ohms. The plus minus 5% says when you actually measure this resistor, it can be anywhere between, 1,000 minus 5% up to 1,000 plus 5%. So what's 5%? Well, that means we're talking about plus minus 50, right? So it could be 10,050, it could be down to 950, if I'm not making a mistake there, okay? So it's just a tolerance. It tells you how accurate you expect the resistor to be, and it can be anywhere in that region, right? It can be anywhere in the region. But ultimately, you should go measure to figure out exactly what the value is, and that's what we'll do. Okay. So I hope this is somewhat useful, and I'll post this, and you can find many of these things on the internet. You may even find apps that you enter in the colors. So you may enter in like orange, 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 and it tells you it's 33K, for example. There are apps like this. All right. So I hope that gives you an idea about what these colors mean. So you can always refer to a table like this, or look it up. Have a web page open that has this information on it. So it's quite straightforward. Okay. So the next thing is, again, what we're really talking about is, we're going to build this circuit. And so we now know how to, that we need to get resistors, and how the resistor color code works in case we look at a resistor, want to determine what the value is. Then the next thing becomes, how do you measure that resistance? Well, you can measure the resistance by using what's called an ohm meter, or in the general case, what's called a multimeter. So what you're seeing here is what we have in the lab. This is a multimeter. A multi meaning that it can measure voltage, current, or resistance. Okay, so it can measure voltage, current, and resistance. And depending on what you want to measure, you hook up your cables here differently. So if you want to measure, for example, you want to measure voltage, you will put your probes at this terminal here, and at the terminal down here. So that will be basically your cables for voltage measurement. Now, when you're in the lab, of course, these are already hooked up. I don't think you'll need to put any cables there, but you'll get there'll be two probes here, red and black, and you can measure, like I said, volts. You can even measure amps or ohms. So if you want to measure resistance, you just click on this little button that says ohm to W. It's called a two-wire resistance measurement. So it means just gonna have two terminals, and your probe, your cable, is gonna have two terminals, red and a black, and you'll simply put it across the resistor, and the multimeter will display exactly what the resistance is. There's nothing to really do. It automatically scales itself and everything. So it's quite easy. So once you do one, and get used to it, it's really quite straightforward. So the point is to just get started, and we have plenty of time in the lab to actually do that. The lab actually is not really long for the specific purpose that you will have time to figure things out. And obviously, part of the learning process is to figure things out for yourself, and and you'll see that it's pretty straightforward. Anyway, we can measure both voltages and uh, currents and resistances with this meter. It's called a multimeter. So multi meaning multiple measurements. Okay. Now, the next thing, if you notice, so we know that we can measure resistances with this. So if you notice here that we have a power supply. So the power supply here is 10 volts. So how are we gonna put a power supply here? Well, we can put a battery, right? A battery will give us the voltage that we need. But in general, in the lab, we use something that's a little more flexible, where we can dial up any voltage that we want, and that's what we call a power supply. So what you see down here is the power supply that's in the lab, and so you can see over here that there are multiple outputs with the positive and the negative. So you can basically attach probes or attach cables to the positive and the negative, and basically choose your output, saying, let's say, output number 1, power supply number 1, and choose your voltage by using this dial, and that's basically it. You just basically dial up whatever voltage you want, and this particular power supply, this device basically can supply 3 separate voltages, 2 of them being adjustable, output 1 and output 2, and the third one is fixed at 5 volts. So basically, if you want to dial up a 10 volt source with this one, obviously to turn it on, this is the on button, and then you'll have 2 cables, maybe a red and a black, that goes to our circuit, which I'm going to show you in a second, okay, how we're going to build the circuit. And once you've done that, right, you're basically going to say, I want to dial up 5 volts, okay. Now, how do you know you have, or 10 volts in our case? So let's say we're going to have 10 volts. You'll see that it shows you that it's actually 10 volts here. So it'll show you 10 volts. Don't worry about this current. This current is the amount of current that's limited, right? So this power supply is protected so that not too much current is supplied to the circuit. It's for protection mainly. But you can see exactly what voltage you're setting up. And you can always double check to make sure that this is the right voltage by basically dialing up the correct voltage, as you see, and then taking your multimeter, right, with the probes. You'll have these 2 probes. They look like little pens with metal tips, and then you could actually put the tips of your probe at the red and the black and see if you are indeed setting up 10 volts. It's just a double check, right? And that's why it says is warning, always check the voltage readings before making connection to your circuit. What that means is, okay, make sure not only are you reading the correct voltage here, but as you put the multimeter here, okay, that you're reading the correct voltage. Then now you've double checked your work. And of course, your TAs and your undergraduate assistants that we have in the lab can help you with that. But it should be pretty straightforward. So all we're doing here is just setting up 10 volts to be applied to the circuit. Okay. So again, what we're doing is we're just basically have our components here. We have our resistors. We have our voltage source set up, and then you have to wire these things up. Okay. Now the question is, how do we wire it up, and where does the wiring take place? So first of all, unlike real, heavy-duty circuits, we're not going to use solder. We have what's called a solderless breadboard, and the breadboard looks like this. At each bench, I'm sure you've seen these boards. This is called a bread box for historical purposes, but this is a way for us to connect circuits up without having to use, a soldering iron and using solder and things like that, which could get dangerous. Could get dangerous because there's heat involved and so on and so forth. So a structure like this, a box like this, allows us to do the connections without having to resort to using this soldering iron. Okay? So besides the bread box, you will see that we have short bits of wires that are in the lab that you can get from the back of the lab. They're basically everywhere. You can pick them up in the back. So those are also used to connect up the circuit, besides just the cables that we have and the resistors that we have. So let me describe the breadbox here for you. So typically, what happens is that your let me zoom in a little bit so we are a little closer to the circuit, because we're just going to need only a portion of this circuit to begin with. Okay, so basically these holes represent the places where you're going to put the one side of the resistor, the sides of the resistor, basically the wiring, the leads of the resistor, and also the wires and also the cables. So typically what happens is the power supply that we had seen, the power supply cables that you will get will basically plug in to these terminals here. Typically, just to stay consistent, the red or the positive side of the power supply you'll plug here, whereas the negative side of the power supply you'll plug here. Okay, and the resistors, they'll be connected to either the top here or the bottom. You can actually choose it anywhere. Typically, you'll choose it to be as close to the power supply pins as possible. So you'll be placing the resistors here. Now the question is, how do you place them, right? It's really up to you. There's really no rules, but you should know how these holes are internally connected. That's the key. Okay, so let me show you roughly how these are connected. So first of all, these rows up here are connected internally. So for example, this top row is all internally connected. What that means is, if you wanted to connect two devices, let's say a wire and a one-sided resistor, placing them anywhere on the top here will kind of make that connection for you. Okay, so once you put something here, anything else that you put here, those will be basically connected. So it's as if you're kind of soldering them. Okay, so this top row, okay, so you notice there's 5 sets of 5 holes. So these are all internally connected. So these 25 are internally connected. Similarly, okay, so let me get another color. Similarly, this bottom row over here is all internally connected. Okay, so again, those are not connected to each other, but the top is all connected together and the bottom there is all connected together. Very similarly, okay, these bottom two, okay, kind of mimic exactly what's going on top. So this row here is all connected. Okay, but it stops here. So these are not connected to the first set, right? So again, on top, these are all separate. They're not connected to the left side. So once again, this side here, these are all connected together. Okay, so once you know what you're looking at, you notice that those 4 sets are separate connection points or nodes. Okay, so if you wanted to connect something together, this is something you could possibly do. Okay, you could have those as nodes. You decide which one to use. Okay, there's no rule except that these are the connections. So based on this, how would you connect it? It's up to you. Okay, now in a very similar way, these columns are internally connected as well. So like, let me get another color. Let me get maybe yellow again here. So like, or green, as the case may be. I can't tell colors. So these 5 are connected together. Okay, but the next column is not connected to the first set. So the next column is separate. So this column is another set, right? And then here, this is another set, and so on and so forth. So these columns are all separate, but each set of 5 is internally connected, right? And you will see a little trough here in the middle. This trough is a kind of a little like a little river, right? So the set of 5 on the other side are separately connected. So this set down here is not connected to this set up there. So that's another set, right? So if you go down here, these set of 5 is also all connected together. Okay, so I'm probably giving you too much information, but I'm just letting you know that This is how they're wired up. So these are all different, right? So you can see that these are the connection points, and based on that, you may determine as to, you know, how you're going to build your circuit, right? And similarly, knowing that you have the plus, right, and the minus side. Well, those are bad colors. I should choose a different color to show you what that is. So you have the plus here. That doesn't work either. Anyway, maybe I should choose blue. Okay, so this is a plus, right? And this is the minus down here. So if you want to, okay, and this is up to you, you can say, okay, I'm going to put a little wire here, right? And I'm going to make my connection from here to the rest of the circuit using these connections. So there's little holes here. You can use those holes as the connection points from the power supply to the rest of the circuit. Or there are places, so these are little, these screw up and down. You can even stick your wires inside the holes under here. When you inspect it in the lab, you'll see what I mean. So you can either use these holes, or you can actually use the connection points under these round holes. So that's how you connect the power supply to the rest of the circuit. But the point is, this is the wiring, and so once you understand this upper left-hand side, then you know they just continue on to different quadrants, and as you can see, there's 3 of these strips, right? 3 of these strips. But for the purposes of this experiment, it'll be sufficient just to use this upper left-hand side. That's the key. If you're in the upper left-hand side, I think you should be okay, because we only really have just 6 components, and that's plenty of space. It should be plenty of space. So if I go and undo some of these things, I'll show you typically maybe how you may want to wire. Again, this is a suggestion, okay? It is not, you know, it's not a must. It just may be typical, you know, if you do want to do it this way. So what you may want to do is maybe you say, okay, so again, maybe you have to have in mind this circuit, right? So I have this H-looking resistor kind of a collection. So how do I want to connect this up? And so here's where visualization comes in. You have to think about how you want to lay this out. And I want to stress again, there is no single way of doing this. There is no single way of doing this. So whatever way works, whatever way the connections are made, you double check your connections. If it works, it works. If it doesn't look pretty, it doesn't look pretty. It's not supposed to look pretty. Okay? So I don't want you to get frustrated if it doesn't look like exactly like what's looking here. It is not going to look like that. Okay? Just letting you know. So what you may want to do over here, and so I'll just you know, and this is just going to be an example. So I'll just go and typically draw for you roughly what I would do here. Okay, so what I would do is, let me pick up the pen size here for you so you can kind of see it. All right, so we'll just try this out. So what I would do is, maybe I would say, okay, I want to make this top terminal be one of my nodes. So for example, maybe I'll have a resistor from this point to maybe somewhere over here. Okay, that could be a connection point. Okay, so now what have I done? Well, I've just made you know, this top column here, the top column that's shown here, all the way across. So we're talking about the column that's, sorry, the row that's over here. So now this top would become one of the connection points. So if I connect another resistor there, okay, that means top of those resistors are connected. That's what it would mean. Okay, so that's something you can do. Do I have to use that particular one? No. Do I have to connect it to exactly the point that I did? No. I could do it this way, right? I could do it this way. Let me erase everything. Okay, so I could do it this way. I could go from, let's say, this point here, have a resistor and connect it down there. Okay, and I can have another resistor, let's say from here, and connect it down here. Now I connected two resistors. Okay, and uh, this top is one of my nodes. So maybe if I go back to the picture here, you realize that, hey, R2 and R4 are connected on top. So maybe I'll make those R2 and R4, right? So maybe I'll have, this will be my 27K. And what was the other one? 33K. And of course, the top of those are connected. So I don't have to really worry about wiring that. It's already internally wired, right? Um, now, um, do I have to have it here? I mean, I could take this 33K, put it all the way on the other side, right? So I could take that and move it, right? I could take it and move it. And you might have to move something because you might say, oh, wait a minute, it's not fitting exactly right. I want to move it. I'm just going to give you an example. I'm giving you an example, right? So there's no, so I can take this and say, okay, you know what? I'm going to erase it. Take a look here. Okay, I can erase this and I can simply move it over. I'm just gonna leave it for now, okay? But how you make it is up to you. It's kind of up to your taste, basically. Okay, so let me show you how to make the other resistor, right? So 47K. I'll put the 47K from the middle. So let's do that. Okay. So maybe I'll take this point here. I'll take this point and I'll put the, excuse me. So I'll go from here to here, right? That's going to be my 47K. So now I made those connections, right? So because now these are internally connected here, and these two are internally connected. So I'm kind of set there. And then what else do I need? Well, I got 20K and 7.5K. Okay, so I can do them this way. Okay, so I'll go from here, and I'll go. Okay, I'll go. Let's say maybe from here. All the way down here. Okay, and you may see why I'm doing that is because this whole column, I'm sorry, row here is connected together. So if you look over here on the schematic, 20K, 7.5K, right? They're connected together. So what I'm doing is I'm simply going and taking care of that. So 20K, this is 20K, this is 7.5K, right? So I'm pretty much there. I'm pretty much there. The only thing I'm missing is I'm missing the, if you look at the picture here, 6.2K. And 6.2K goes to the top of these two, and it's going to go to the side of the power supply. And then the bottom of the 20K and the 7.5K goes back to the negative side of the power supply, right? So that's the circuit that I see. So I need my 6.5K, and this is the way I'm going to do it, okay? I'm going to put a resistor from this point, okay, from this point, maybe to this point, okay, and this is gonna be my 6.2K, okay. So I don't know if that makes sense, but that's basically the wiring for the resistors, and now it's pretty much wired, except that I need to wire to the actual circuit itself, and for that we'll use cables, right? So maybe you can go from here to over here, okay? That's my connection from the positive power supply, to the 6.2K, and then 6.2K for the rest of the circuit. And then for the negative side, it's quite simple, because the negative side is going to be over here. That's the negative side. Remember, your power supply is going in here, right? This is your power supply coming in from the power supply circuit, right? So this is your plus minus 10 volts. So the negative is going to go, the little wire is going to go from here to anywhere here, for example. So now those are the connections, right? So you can see that the 6.2K is connected here, and these three resistors are connected automatically by this row. Here the 20K and 7.5K is connected on the bottom, and then of course these resistors are connected because they're on the same column, right? So I hope I haven't done anything correctly, but this is one way you could hook it up. There are other ways. There's you should take your time in understanding what's going on, but there's only few things to understand here. It's just understanding that these rows are connected together. So 1, 2, and then 3, 4. Those rows are individually connected. And then each of these set of 5 is internally connected, the columns. But these columns are not connected going across this little trough. So this column and that column, they're not connected. So it's these 5 internally connected separately than these come. Okay? I'm repeating that several times because that is the very, very common mistake. You think you made that connection, but actually they're not connected internally. So this is the way to kind of set it up. I hope this helps you out with the experiment. You'll have plenty of time because there's going to be only one circuit to set up, and you have 3 hours. I think you can figure this one out. But really, there isn't too much to do before coming into the lab. It's just understanding that this is basically it. And your TA will probably tell you this information again. If not, though, you have it here. So I hope that you have a successful lab and you learn something. Again, there's going to be a little bit of a learning curve. You will hesitate here and there because you might not be familiar with this. But I think overall you should be prepared to do this lab. The one preparation, of course, is, for example, to be able to set up this circuit, run the circuit, and get the node voltages up here. You know, we have on the node here, which is basically 10 volts, and then you have a node here, and then you have one node here and one node there. So besides this one, which is at 10 volts, you'll have 3 voltages you need to simulate to compute, basically. That's going to be your starting point. The next thing you will do is you will make another circuit like this, or save this as another circuit, and enter in the actual values for these resistors. After your measurement, they'll be different because there's a tolerance, right? There's a variation. And then you'll rerun your circuit, and your values will be slightly different. So now you have 2 sets of values, the ideal one and the more practical one from the simulation. And then you do the construction of the circuit, right? Construction of the circuit will take some time with the wires and cables, setting up the power supply to the 10 volts. And then you'll be measuring the voltages by using the multimeter. And when you use the multimeter and you want to measure voltage from, for example, from this point to down there, you put the red at the voltage that you want, the node voltage, and then you'll put the black at the common terminal, what we call the quote-unquote ground terminal, which doesn't have to be really ground, but it's the common terminal that all the voltages are being measured with respect to. Okay. So with that, I'll say good night and or good morning, depending on when you're listening to this. And then, like I said, I hope you have a good week, and I'll see you in the lecture. Thanks very much. Until next time, have a good day.